Day 4 Loops and Iterations in C. Welcome to Day 4 of our C programming tutorial series. Today we are diving into one of the most essential and frequently used concepts in programming, loops and iterations. Loops allows us to repeat a block of code multiple times without writing it over and over again. This makes our program shorter, easier to manage, and more flexible. By the end of this video, we will be able to understand the type of loops in C, how they work, and how to use them efficiently in real world problems. We will also look at flowcharts, control statements like break and continue, and explore nested loops with examples. This session is packed with practical insights, clear explanation, and real life analysis to help your master loops. Whether we are preparing for your exams or coding interviews, loops are crucial. So get your notebooks and compilers ready and let's start this exciting journey into the world of loops and iterations in C program. What is a loop? A loop is a fundamental programming construct that allows us to repeatedly execute a block of code as long as a specific condition holds true. Think of it like a teacher asking a student to read a paragraph until they get it right. Instead of writing the same instructions multiple times, a loop automates the repetitions. In C programming, loops make your code efficient, redundancy, and save development time. Without loops, we would need to write out each step manually, which increases the risk of error and boards that code. Loops are not just about saving lines, they also help implement logic that evolves as a program runs. They are used everywhere from printing a sequence of number to reading inputs continuously until a user types exit. A loop checks a conditions and if it is true, the statements inside the loop run. When the condition becomes false, the loop exits. Understanding loops is your first step toward writing dynamic and powerful programmers. In the upcoming slides, we will explore the different types of loops available in C. Types of loops in C. C program provides us with three primary type of loops: the loop, for loop, while loop, and do while loop. Each of these loop structures serves a different purpose and is suited for different situations. Therefore, loops is commonly used when the number of iterations is known ahead of time. It combines initialization, condition checking, and incrementing in a single level, making it compact and readable. On the other hand, the while loop is better when the number of iterations is not predetermined. It checks the conditions before the loop body is executed, which means it might not run at all if the conditions if false from the start. Lastly, the do while loop grants at least one execution of the loop body because it checks the condition after the loop body. This is useful for tasks where the code must execute at least once, like displaying a menu before asking for your user input. Understanding these three types of loops will give you the flexibility to solve a wide variety of problems in the following slides. We will examine the syntax, flow, and usage examples of each loop type to build a solid foundation. Syntax of for loop. The for loop is a powerful and commonly used looping construct in C. It is a syntax is clean and straightforward for initialization, condition increment. Let's break it down. The initialization step is where you declare and initialize your loop control variable. Next comes the condition, which is evaluated before every iteration. If the condition is true, the code block executes. Finally, the increment statement updates the control variable after each iteration. All three parts are placed in the parentheses and separated by the semicolon. For example, for int I equals to 0, I greater than 10, I plus plus is a loop that starts from 0 and run until I becomes 10, increasing by 1 in each step. This loop will execute 10 times. The advantage of a for loop is that all control statements are grouped in one place, make it easier to understand and maintain. For loops are ideal when the number of iterations is fixed. We will commonly use them to iterate over arrays, print sequences, and control repetitive tasks. In the next slide, we will see a complete code example using this syntax. Example of for loop. Let's look at a working example of the for loop to understand its structure and output. Consider this code snippet for int I equal to 0 and greater than 5 I plus plus. Printf, here what happens step by step. The loop starts by initializing I to 0. It then checks if I is less than 5 since this is true. It executes the body of the loop which prints the value of I. After that I is incremented by 1. The loop continues to run as long as I is less than 5. When I becomes 5, the condition fails and the loop exits. So the output will be 0, 1, 2, 3, and 4, each on a new line. This example is a classic demonstration of how to use a for loop for counting or iterating through a known range. You can modify this code to count downwards, skip numbers, or even multiple the iterators. Try experimenting by changing the start value and conditions or increment step to see how to the behavior changes. Practicing these small weeks will deepen your understanding and prepare you for more advised use cases. Flowchart of for loop. Now let's visualize how a for loop works using a flowchart. A flowchart helps us understand the step-by-step flow of the loop's execution. It starts within the initialization where the loop variables is set to its starting value. Next, the condition is checked. If the condition is true, the program enters the loop body and executes the statements inside. After completing the loop body, the increment step update the loop variable. Then the condition is checked again. If still true, the loop runs again. If not, the loop terminates and the program moves on to the next part of the code. This cycle of checking the condition, running the code block, and updating the control variable continues until the condition becomes follows. Visualizing the loop with the flowcharts make it easier to predict and debug the behavior of your program, especially when your loops became more complex. Next, we will look the syntax and usage of the while loop, another important looping construct in C. If you want to, I can help pay the next slide. Need to tune and style, just let me know. Syntax of while loop. Now let's dive deeper into the while loop. This while loop is a control structure that allows a block of code to execute repeatedly as long as specified condition remains true. Its syntax is simple. You write while condition followed by the code block inside braces. Unlike the for loop, initialization and increment steps are handled separately outside and inside the loop respectively. This gives you are more flexibility to control the loop behavior, especially when the number of iterations is not now upfront. For example, you might use a while loop to keep reading input from a user until they type a certain keyword. The loop checks the condition before running the code block. So if the condition is false from the start, the code will not execute even once. One important aspect to remember is to update the loop variable inside the loop to avoid infinite loops. For example, if you forget to increment a counter, if your condition may never become false and your program will keep running forever. While loop is perfect when the iteration depending on dynamic conditions or external data. Example of while loop. Let's look at an example of the while loop in action. Suppose we want to print number from 0 to 4. We would start by initializing a variable I to 0 outside the loop. Then inside the while loop, you check if I is less than 5. If true, you print the value of I and then increment by 1. Each time the condition is checked before the block runs. So when I became 5, the loop stopped. This style is very flexible. Unlike the for loop, you explicitly manage initialization and increment, which can be useful in more complex scenarios where increments were dependent on user input. However, this flexibility also means you need to be careful. Forgetting to increment I or accidental modifying it inside the loop can cause infinite loops are unexpected behavior. So always test your loops thoroughly, especially when using while loops where the stopping conditions can change dynamically. Flowchart of while loop. To better understand the while loop, let's visualize it a flowchart. It starts by evaluating the condition. If the condition is true, the program enters the loop and executes the code inside. After executing the code, the program loops back to evaluate the condition again. This cycle repeats until the condition evaluates to false. At that point, the loop executes and the program continuously with the code that follows. This follow ensure that the condition is always checked before the code block runs. If the condition is initially false, the loop body why not execute even once. This pre-check behavior differentiate the while loop from the do while loop. Compared to for loop, the while loop separate initialization increment operations, offering more control and flexibility, but requiring you to be more careful with the variable management to avoid bugs like infinite loop. Syntax of do while loop. The do while loop is similar to the while loop but with one key differences. The code block executes first before the condition is checked. This guarantees that the loop run at least once, regardless of whether the condition is initially true or false. It syntax that with do while, notice the semicolon at the end of the while statement. The block inside to runs first. Then the condition is evaluated. From the condition is true, the loop repeats. If false, it executes. This structure is very useful when you need to ensure the loop body executes at least once. A common example is a menu-driven program where we want to display the menu first and then repeat based on user input. Remember, unlike the while loop, which might skip the block if the condition fails initially, the do while loop guarantees at least one execution, making it ideal for scenarios where initialization execution is necessary. Example of do while loop. Let's consider an example to clarify this. Suppose we have int I equal to 0 and we write a do while loop that prints I and increment and it, continuing while I greater than 5. This will print numbers 0 to 4 just like the other loops. However, if you initialize it to 10, which fails the condition, the do while loop will still execute the print statement once before stopping. This behavior is perfect for cases like input validation for menu-driven program where the code must execute before the condition is checked. For example, we want to show a menu at least once and then repeat if the user chooses to continue. Although less common than for even a while loop, do while loops are valuable tools when your logic requires guaranteed execution followed by the condition checks. Flowchart of a do while loop. Initializing the do while loop with a flowchart helps solidify understanding. The process begins by executing the code block. After executing, the condition is avoided if the condition is true. The loop repeats and the block executes again. If the condition is false, the loop terminates and the program moves on. The crucially differences from the while loop is that the condition checks happen after the execution, not before. This means the code block run at least once regardless of the condition. This behavior is crucially for use cases like input validation where you want to promote the user initially and then repeat based on their response. Understanding this flow ensure we pick the right loop type for your programming needs. Introduction to loop control. Loop gives us powerful way to repeat code, but sometimes we want even more control over when and how they run. C provides two important statements for this: break and continuous. Break allows you to exit to loop immediately when if the loop condition is still true. This is useful when a certain conditions is met and we want to stop looping early. Continue skips the rest of the current iteration and jumps directly to the next iteration. This helps when you want to ignore certain cases but continue looping. Using these wisely let you write more efficient, readable, and flexible loops. For example, if you are searching for a loop in an array, once found, we can use break to stop searching further. Or if you want to skip invalid inputs, use continuous. Mastering loop control statements helps handle complex scenarios allocated without extra and nested conditions. Break statement. Let's look at how break works. Imagine you have a loop from 0 to 9, but we want to stop when the variable reaches 5. Inside the loop, we check if the variable equals 5. If you so you execute break, this case the loop to execute immediately, skipping an further iteration. This is handy in scenarios like searching for an element in a list. Once found, no need to continue looping, which saves time and resources. Break is also useful in menu-driven programs where the user selects an option to exit the loop. However, use break carefully as excessive or improper use can make your code harder to read. Always ensures it's clear why the loop is being exited early. Continuous statement. This continuous statement allows you to skip the rest of the current iteration and move directly to the next one. For example, in a loop from 0 to 9, if the variable equals 5, you continue skipping the print statement for that iteration. This means all number except 5 are printed. Continue is very useful to avoid nested if else statement when you want to ignore certain cases but continue looping. For instances, skipping invalid data entries or filtering out unwanted elements. It helps keep your code clean and easy to understand. But like break, use continue thoughtfully to maintain to clear logic flow. Break versus continue. It's important to distinguish between break and continue. Break completely exit the loop immediately, no matter what remains. Continue skips just the current iteration and proceeds to the next cycle. Use break when your task is done or certain conditions ends the loop permanently. Use continuously when you want to ignore specific iteration but continuously looping through the rest. For example, in processing data, continue skip bad data points while break might end processing if a fatal error occurs. Understanding these differences control let you control loops preciously, improving efficiency and readability. What are nested loops? Nested loops are loops inside other loops. Imagine a table with rows and columns. To print every cell, we use a one loop for rows and another nested inside for column. The inner loop complete all its iterations for each iteration of the outer loop. Nested loops are fundamental in many programming scenarios like matrix operation, pattern printing, and game development. They allow you to handle multi-dimensional data structure efficiently. Understanding nested loop is crucial for complex problem solving in programming. Nested for loop example. Consider a nested for loop example. The outer loop runs from 0 to 2, representing rows inside it. The inner loop also runs from 0 to 2, representing columns. Each time the outer loop runs once, the inner loop runs completely. Printing I and j show every combination of row and column indexes. These prints all page from 00 to 22. Such nested loops are essential in traversing 2D arrays or grids. Mastering needed loops enables you to work with more complex and data structure efficiently. Nested while, do while example. Nested loop are not limited to for loops. You can nested while or do while loops similarly. For example, with while loops you initialize I and j. Loop j inside I. Incrementing j inside its loop and I outside. The key is correct initialization and increment to avoid infinite loops. The logic remains the same for each I run through all j values. This structure works well for dynamic conditions or user-driven loops. Using different loop types together gives for flexibility in solving problems. Use cases of nested loops. Nested loops are used in many practical programming tasks. Printing patterns like triangles or pyramids involves controlling spaces and stars with nested loops. Metric operations such as addition or multiplication really and nested loops to process rows and columns. Game boards like TIC, TAC, TUOC are just use nested loops to handle grid-based logic. Displacing tables or 2D arrays on screen also require nested loops. These use cases show how nested loops are foundational for multi-dimensional data handling. Understanding them open door to more complex and interesting programming challenges. Common mistakes in loops. When working with loops, programmers often face common pitfalls. Infinite loops occur when the exit condition never becomes follows, often due to missing increments or wrong conditions. Often by one error happen when loop run one too many or one too few times, like starting at 1 instead of 0. Incorrect increments such as modifying the wrong variable of incrementing inside nested loop improving case bugs. Always test your loops carefully. Use print statement to bug values and review loop logic thoroughly. Good debugging practice save time and improve and code reliability. Tips and best practices. To write effective loops, keep nesting level shelf. Deeply nested loops reduce readability and increase complexity. Use clear and meaningful variable names like row and column instead of I and j for better clarity. Test loops with edge cases such as empty arrays or maximum iterations. Prefer for loops when the number of iterations is known. Use while for unknown or dynamic conditions. Comment your code, especially your complex loops, to help others and future you understand the logic. Following these tips leads to cleaner, efficient, and maintainable code. Real world examples. Loops are everywhere in programming. Printing multiplication table uses loops to generate rows and columns. Use validation like checking usernames and passwords often requires loops to handle multiple attempts. Menu drive programs such as ATMs or calculators really and loops to repeatedly show options. Simulation and animations use loops to update frames continuously. Understanding the loops enables you to create dynamic responsive, and interactive, and programs that handle real world tasks effectively. Mini project. Let's apply what we have learned in a mini project. Write a program to print a pyramid pattern like this. Use nested loops, an outer loop for rows and two inner loops, one for printing space and one for printing stars. Allow the user to input the size of the pyramid. This project helps reinforce nested loop and introduce due to pattern printing an essential programming skill. Experiment with the different sizes and patterns to build your confidence with loops. Recap and key takeaways. To summarize today's lesson, loops help you repeat code efficiently without duplication. Choose the right loop types for when you know iteration while do while for unknown counts. Control loops with break and continue for flexibility. Nested loops solve multi-dimensional problems like matrices and patterns. Practice is key. Debug and experiment to master loops. Thank you for joining this session. Keep coding, and we will soon be writing clean and efficient program with loops.